Well, welcome everyone to TUG 2021 and our next presentation, which will be from Joseph Wright of the LaTeX 3 team on any color you like.
Hello, my name is Joseph Wright, and today I'd like to talk to you about work I've been doing to support colour in Expo 3 in a module called L3 Colour. Colour is already quite well supported by a number of other packages, and so we're going to move first to some acknowledgements, and that's to recognise the existing packages from which I've taken ideas, inspiration or hints. Probably most famous of these is the colour package by David Carlisle, which provides core colour support for LaTeX, and we'll see that it abstracts out the central idea of how TeX deals with colour into a model we can use as users. Uwe Kern's xcolor package is again very well known and is used to extend colour in a number of ways, in particular bringing in an idea called colour expressions, and we'll be seeing how they're implemented in L3 Colour shortly. I then want to reference some code by Javier Bezos. He's written a package called colorspace, which supports the idea of what are called separations. And the final packages I'll be referencing are a couple by Heiko Oberdiek, PDF Render and luacolor, and we'll see that they cover two aspects of dealing with colour that lead to some sort of special effects. So our starting point is the fact that TeX doesn't in itself support colour, but rather we have to use specials. We have to tell the back end that we're using about the colour, and then it leads to the text being coloured. And that means that fundamentally you have to have different specials for different backends. And as a user, that's not really very convenient, certainly as a LaTeX user. And so David's colour package abstracts out the different backends into a single interface for users. And so the starting point for all colour support is that. As a simple interface, here's a colour, make it so. There's more to colour though. So I've already referenced the idea of xcolor, making mixtures, colour spaces, additional effects. And we've just seen in my introduction that I've referenced a number of packages. So what we're really trying to do in Expo 3 is in many ways bring those together. I will point out where we're trying to go a little bit beyond what's currently available as well though. Yeah, so we're going to try and use some newer engine features as well. So there are places where older packages simply didn't have the facilities available to do certain effects. So we're going to start in the same place David does, and abstract engine-dependent color into a document, or in this case, a code interface. So if we've got an explicit color model, and red, green, blue, I think we all know what red, green, blue means. We have three values there, and you can see that in typical Expo 3 style, we have a name color select, which tells us with that colon NN, we take two arguments. Or we can have a named color, and we can select that's only one argument. So here, blue, which is the blue component of red, green, blue, predefined. That's pretty straightforward, and that's only doing what the color package does. But it's a starting point. The next thing we want to do is mixtures, and the idea that most of the time, most of us would like to predefine a few named colors and talk about how we mix them based on ratios between them. That's an idea that xcolor brought in. And here we've simply adopted the same syntax that xcolor has for an expression. Now, xcolor has two kinds of expression. I've only supported one at present, which is this simple syntax where you have a named color, exclamation mark, an amount, an exclamation mark, another color, and you can go on. And you can see that I think in a document or even in a piece of code, that first line is a lot more readable than the second one. And this is for a simple mixture where I've just taken some red and some blue. I haven't even tried to do multiple mixtures. So again, that's something we can already do in xcolor, but we've built this into the same interfaces as the basic color. Now, we've just mentioned a couple of times models there. What's a color model? It's a way of describing colors using different parameters. And there are three what I'm going to call native models in L3 color. They're grayscale color, so that's between 0 and 1 black, red, green, blue, between 0 and 1 for red, green, and blue components, and cyan, magenta, yellow, black, which has got 4 components, but the same idea. So just as a reminder, red, green, blue is useful for screens because of the physics of how screens work, but the cyan, magenta, yellow, black is useful for print. Why are these native? They're native because they're the 3 models which you can put straight into a PDF. You can use them all in PostScript. If we're using SVG, it's a little bit more complicated, but essentially these are models that if we have a color defined in them, we can just use. There are other models. Xcolor defines a few of these. So we've got hue, saturation, brightness, HTML format, which is 3 hex values, integer-based red, green, blue, that's between 0 and 255 for red, green, and blue components. There are others. So we want to support all of those. All of those have been built into L3 color. The difference is that those later 3, the non-native colors, are converted when we store them into a native format. And that means we have some built-in conversion. So here at an implementation level, I can do something that Xcolor can't. And that's that I can use the L3FP. So what does that offer? It means that the expressions are easier to read in the code, and it also means we don't have to worry so much about rounding issues. Xcolor uses a classical diamond-based approach to doing floating point arithmetic, and that comes with a few limitations, and we just avoid those. What happens when we mix colors from different models? Well, again, following Xcolor, the first model wins. So if we take here, we mix some red, which is an RGB color, and cyan, which is a CMYK color, and then we show the result. Oddly enough, we get a color which is RGB based. And what that tells you, of course, is that internally we have some code to also convert between native models. Now, it turns out, again, if you read the Xcolor manual, that there are lots of subtleties to conversion. CMYK to RGB is straightforward. The other way is less straightforward. At present, I've gone for a simple implementation there, but we've got flexibility to extend it should that be needed. So yeah, we've seen we can convert models, but what if we want to specify the model? So I say conversion is non-trivial, and you might say, well, I know that if it's printing, I want one set of colors. If it's on screen, I want a different set. So we can define data in multiple models. And what will happen is L3 color will store both of those. It'll prefer the one that's given first, but if it's asked to mix or convert to the second model, it will use the predefined data if it's available and only use the expression, the calculated version, if it has to. Now, there's this subtle difference here from Xcolor. And that's that in Xcolor, you have a similar syntax, but what Xcolor does is it sees which model is currently active and it stores that information. So if we'd fixed that all colors must be RGB, it would only store the RGB values. In contrast, L3 color stores both, and it's at the point of use that we look at this. So if we get a mixture that needs RGB, we use RGB. If we get a mixture that needs CMYK, we use CMYK. And you can, in L3 color, in the same way as Xcolor, you can say convert all colors to a particular model, and again, it will use L3 color will use that information if we've got multiple models. We can also export the data. So here, let's say I wanted to export in HTML format. What would I get? I'd get something that looks like this. So you see 3 hex values in capitalized letters. Why would I want to do that? Well, I didn't quite give you the full truth about how colors managed in tech earlier. Yes, for running text, color is managed with specials, but there are places where we need to give color for specific commands, particularly when creating hyperlinks. And so hyperlinks actually need the color specified in HTML format. and that's what's going on here. So we can export to give colors in different places that can be used outside of the ones managed by L3 color. Or of course you might just be interested in what the result is. Now that's something that's actually covered at present by Hyper-Ref in a slightly different way, but because it's built in, we know we're using exactly the same converters as we would for input, say. So it's a more straightforward, easier to understand setup. So that takes us to the idea of color spaces and spots. So this is a print concept fundamentally. We can use defined inks. Now they're called spot colors normally. I'm going to use the term separation because that's the term that's used by the PDF spec. Now I'm just going to put a caveat here. We have built-in code for this area. In general, it only works if you have PDF management loaded, which Ulrika will talk about, and it's currently in a test phase. However, it's not absolutely required because if you're working in a PostScript workflow, this code does work without that. And it's to do with exactly how one has to implement things at the back end. So what's a new model? So what happens here is we create a new model separation, and this one I've called bar tone. This is based on an example from the color space manual, and we're loading a defined ink where I've given an alternative model as a red, green, blue. What's an alternative model? Well, it's the idea that if we've got a defined ink, if we don't have that ink available, we need to put something on the screen or print something. And the way we usually do that is we define an alternative value in another model. So here I've given RGB values. So as I said, this is an example taken from the color space manual or adapted from there. And the color space package can do this for PDFTech and LaTeX. But because of engine developments, we can do it for ZTech. And sitting and grinding through the PostScript, I've also worked this out for a DVI-PS based workflow. So this will work in DVI-PS. In fact, it's strangely for the user, it's slightly easier, as I say, because PostScript deals with some of the management in a way that PDF Tech needs the management code. So that's one kind of separation we could create. We could also use what's called a device-independent CIE lab color. Now, what the heck's that? Well, when you use RGB or CMYK, the color that you get depends on the physics of the output device you're using, the screen, the inks, etc. And so to get comparable colors, we'll see in a little while, you have to do some work. But one way you can do that is you can define a device-independent color, and that's where CIE lab comes in. So rather here than using an RGB alternative, I've used a CIE lab. Now CIE lab has 3 values, which are the L star, AE star, and B star values, and what's called an illuminant, which is required, and there's a few values. This one I'm using is D65. There's a few. It's not as though you can just pick a number there. They're defined things. So that's built in. What's important to say is here that these separations can be used to define colors that we can then create mixtures from in that xcolor-like syntax. Why am I highlighting that? Well, Javier's color space package tries to patch xcolor to do the same, but it's limited in what it can do because it's patching another package. Here, this code is built in from the word Go, so you can always use these systems in mixtures or in what's called tints. So you can't really do a mixture with a CIE lab color because it's a defined arbitrary color. You can use a tint though. You can say use 50% of the ink and let the paper do the rest, etc. And so that's something that we can do here. The other thing you might want to do is actually have, if you have separation, you might have more than one separation, or you might want to be able to define a situation where you put separations down with process colors, normal inks. And the PDF spec calls that a device N color space. And we can create device N color spaces as well. So here I've taken my bar tone color mixed with cyan, magenta, yellow, and black. And that would mean that I would, rather than RGB, which has 3 values, or CMYK, which has 4 values, Here you will see I'd have a color. If I used this new model, which I called all in, I'd need to give 5 values in order to describe the color that I'm using. Fill, strokes and stacks. Yes. Okay, so probably you don't think about this, but when you print text, are you using the fill or the stroke color? And it turns out in a PDF, you are using the fill color and not the stroke. Where does this come into relating to stacks? It's to do with what color stacks are. So what's a color stack? A color stack is a way of tracking color between page breaks. PDFTech and LaTeX have multiple color stacks. DVI-PS classically only has one. Older DVI PDFMX only had one. Newer releases have multiple stacks. But it's not actually a color stack. It's actually a graphic state stack. We can put other things onto it. So we could talk here about making transparent, opaque printing, and that would be in the same area. But what I want to focus on is the fact that the PDF spec has the idea of a fill color and a stroke color, and they're separate. So the PDF render package lets you set those ideas independently, but L3 color does the same. So that would mean that you can set the fill color only for text or the stroke color. Now at present, we haven't covered the idea of telling a PDF only to use the stroke to give you kind of outline text. But once we do, having fill and stroke managed separately for color will be useful. The place that you probably see fill and stroke colors most obviously is in drawing graphics, things like ticks. And there you don't need to worry so much about a stack because they don't break over pages. But what we're trying to do is use the fact we've got better facilities in the engines to integrate these ideas in together. So this is quite a specialist area, but I've been trying to work on that. I would love to find a way of having multiple color stacks in DVI-PS, or if someone knows how to do it in PostScript, I would love them to tell me because I haven't been able to work that out. Just to point out, PostScript doesn't have fill and stroke colors, so the way that that's implemented is slightly different. And so it's probably simply not possible to do that in PostScript. I've already mentioned the idea of device color, the fact that colors are dependent on the system you're using to do your printing or your display. So there are ways to fix that, and they're called color profiles. Now, again, this is something that's in the colorspace package, but again, I'm trying to extend it to other engines. And to give it a slightly more integrated interface, so there's a couple of ideas here. Now then, as you'll see here, it says it's a pull request. It's not integrated at present. I would love thoughts on this. So the first approach you can take is you can apply a profile, which is a binary file basically, to an existing color space. And so it's my suggestion, apply color ICC profile apply. And what that does is then it modifies how RGB is used here to use this profiled color space. The other way you can do it is you can create an entirely new model that would leave RGB alone. So you'll see here I've got a new model called ICC based, which only has this one file. Now, this is one of the areas that I've had some help from Marcel Kruger, because it turns out you can find out what type of color space is inside an ICC profile using a bit of binary code to extract some binary information. Those two interfaces both have advantages and disadvantages. I suspect we'll end up adding both to L3 color, but at present I'm waiting on feedback from the team, so I'm hoping that they're listening to this talk and we'll progress things a little bit here. But the idea is we're going to integrate, again, that into this core. And the final thing to talk about is whatsits. So I told you right at the start that tech doesn't understand color and we use specials. And a special leads to inserting a whatsit in your output. And whatsits are problematic. They limit certain aspects of what we can do, and it leads to a famous footnote in the graphics manual about where you have to be careful about putting colors in. LaTeX offers us a way out of that. So LaTeX allows us to use what are called attributes. Now, an attribute is just a number. So we have a list of numbers, attribute 1, attribute 2, attribute 3, and each attribute can have a number. And those attributes follow around the node when they're defined. So node is like the letter, basic level. Why is that useful? Well, if we create a lookup table, we can say, well, this attribute is the color. Color number 1 is 50% blue, color number 2 is 25% blue, etc. And because those attributes aren't using whatsits, they don't lead to the problems that the whatsits special based approach does. Now, it turns out the way that you do this is you follow the code round, and you actually have to do a pass just before you output your material to put the color in. And Heiko did this for LaTeX 2e in a package called luacolor. I've been working with Marcel to come up with a version for L3 color. Again, this is not integrated yet. There's some changes between our code and Heiko's code, partly to do with having ship out hooks in the LaTeX kernel now, partly to do with some slightly cleaner ways we can do the Lua, and partly to do with the fact that Marcel has spotted a better way to fundamentally handle the color nodes. Although it's not integrated yet, I think it's likely that colors defined using L3 color will use LaTeX attribute table for color at some point in the not too distant future generally. So in other words, it won't be an opt-in, it will simply be on. LaTeX 2e is a bigger question. Do we try to actually integrate that idea into LaTeX 2e? Open question. Because the moment you change how the color works, you can have a knock-on. Although if people have done color the way they're supposed to, they should get no change. So in summary, L3 color is about having a single set of interfaces which integrate lots of ideas that already exist, but bring them together and bring in some new features, a chance to explore what's possible. So things like new engine developments. Can we solve how to do color spaces in PostScript? Can we apply luacolor directly? So that's what L3 color is about, and it's also about the fact that because it integrates to the rest of xpool3, you get the same safe, consistent interfaces. There are things I haven't done. I'm just going to point out that xcolor has an idea of doing color for tables, and it's done a slightly odd way. And the reason I haven't implemented that is because xpool3 offers us lots of loops where we can easily define multiple values very quickly, and so that type of thing is better handled using the other programming tools in xpool3. So L3 color is really about bringing those programming tools together with best quality color management we can and offering that up as part of the core of xpool3. So I hope you enjoyed that. Thank you very much for your attention.
Well, I'm afraid we don't have Joseph here with us live, so we can't ask him any questions. But does anyone have any comments?
I was surprised by his remark that in PostScript you wouldn't be able to do fill and stroke colors because you have the fill and stroke command and you can set the color in the graphics state, which is basically a stack that you can push and pull.
Anyone else?
I think the issue there is basically that in order to change one of the, especially if you change them to different values, that you really need to coordinate with the code which actually draws, and you can't just set some state in the beginning and then get it, then that it's used correctly automatically. That's the main issue.
Marcel, can you comment on when this will be sort of ready to try things out, to experiment with the package?
I think most of it already is ready. I mean, the question is, of course, which part you mean specifically. But if I remember correctly, it should already work right now. And you probably should use PDF management test file right now, especially if you want the CIE colors and similar stuff, but mostly it should work. I mean, the LaTeX stuff will still change and the ICC colors are not there yet, but the remaining stuff should already be usable.
Mhm. Thank you.
Any other comments?
There is a comment by Jersey on the chat, and I don't know if Marcel wants to address that.
Personally, I haven't looked into what we are doing with tables, so I can't comment on this.
Okay. We have, unless there are other comments, we have 20 minutes until the next presentation. So we can take a short break and be back